Hi Zach, so I'm making you a video because I'm working on my physics lab and my giveacrap just broke. So I'm wearing the thing that your sister got me, the little that was things just fell. Oh god. Anyway. So let's see, what did I want to tell you about?
I got a flu shot.
Kelly got a flu shot and she didn't pass out.
Nope.
Yay! And I gave her a superhero band-aid cuz she needed one. Anyway, so I'm going to tell you about what we did in biochem today.
Oh god.
It was so depressing. Like, Dr. Saderholm is sort of just like, yeah, everyone in my wife's family died of cancer, which is sad. I mean, yeah, totally. But it's just sort of like, whoa, way to bring me down on a Friday, dude.
Mm-hmm.
But so that was awful and terrifying. And then we talked about DNA recombination and why sex is important. So I'm going to tell you about that. So, DNA recombination is when you have sort of two strands of DNA and they sort of are cut or they break and they switch and they sort of mingle and stuff gets switched around. That's a pretty good, like, just sort of summary. Anyway, and the reason it's important is because if we if we had asexual reproduction, all of us would essentially just sort of be clones, right? So we would all have sort of the same genetic material. And that would be good, like if you took like this superhuman guy and just cloned, you know, and he just asexually reproduced and we were all just like this fantastic person, that sounds great. Until a new virus or a new environmental factor shows up and we can't, we have no way to deal with it. So for instance, like antibodies, the way antibodies work, you make about 6 million? You make about 6 million antibodies, and so your body just sort of makes a bunch of antibodies and kind of just hopes one of them will work. And so some people have actually got antibodies for the AIDS virus, which is awesome. And if we asexually reproduce, we wouldn't have that. So because of DNA recombination and sexual reproduction, we can mutate. And sometimes the mutations are good, and sometimes the mutations are bad, and sometimes the mutations are superfluous, but they're good and bad sometimes. But yeah, like achondroplasia. Achondroplasia is a single gene. Oh, achondroplasia is dwarfism. It's one of the most common kinds of dwarfism. It's the kind that most people, when you think of a dwarf, you're probably thinking of an achondroplagic dwarf. But anyway, it's a single gene mutation. It doesn't run in families. What happens is you're just a normal couple. Somewhere, a gene gets turned on that wasn't turned on before because it is dominant. And then you end up with an achondroplagic child, and then that child has a good chance at what, I think it's a 70%. I don't remember the ratio exactly, but they will have achondroplagic children. But anywho, mutations are good because they help us, like sickle cell anemia. That's a good one. Sickle cell anemia helps prevent malaria, but it also causes blood clots and other bad things. But it was a mutation that caused people in malaria-prone regions to survive malaria, so they kept having children, and now there's people with sickle cell. Okay, this was very rambly. This was a very rambly thing, but yay! I taught you about DNA recombination, sort of. I'm not a very good teacher. Oh well. Good thing I'm not trying to be a teacher. Alright. Bye.